Hey guys, let's do lesson 6.11. Your learning target for this lesson is I will be able to combine like terms. So the first thing I want to do is I want to define like terms. Like terms are terms whose variables and exponents are the same. Okay, so for example, 5x and x are like terms because they're both using the variable x and neither of them have an exponent. The number up here in the front, the coefficient, that really doesn't matter. This could also be over here, this could be 2x, and they would still be like terms, and they're like terms because of using that variable x with the same exponent. Okay, in this case, no exponent. All right, so look at your think about it. It says Victoria and Joey want to write an expression to represent the perimeter of the rectangle below. Okay, so Victoria wrote the expression n plus 1 plus n plus 2 plus n plus 1 plus n plus 2. Joey wrote the expression 4n plus 6. Whose expression is correct? Explain. Go ahead and pause the video and work on the think about it on your own, please. All right, guys, hopefully you paused. So we are going to go ahead and we are going to do, we're going to use substitution just like we did in lesson 4.10. So we are going to substitute a number in for our variable n. So let's just pick an easy number. We'll pick the number 2. So we're going to say n is going to equal 2. Okay, so don't forget the formula for perimeter is going to be 2 times the length plus 2 times the width. Okay, so let's go ahead and solve based off of that formula and plugging in the length and width. So for the length, we have n plus 2, and for the width, we have n plus 1. Again, we're going to substitute a value in for the letter n. And it's going to be 2. So equals 2 plus 2 plus 2 plus 1. Okay, so now we have to solve using the order of operations. We have to solve what's inside of parentheses first. We have 2 sets of parentheses, so we need to do them in order from left to right. So we have to do 2 plus 2, which is 4. My one change, and I bring everything else down. Okay, now we work on the second set of parentheses. 2 plus 1 gives us 3. It's our one change, and we bring everything else down. Oops, I forgot my parentheses. Okay, now we have 2 multiplication problems, which are done in order from left to right. So we have 8 plus 2 times 3. Then we have to solve 2 times 3, which is 6. And 8 plus 6, we know, is going to be 14. So if Victoria or Joey's expression end up being 14, then it sounds like they have the correct expression. So let's test those out. Okay, so we have Victoria. Let's write hers out. We have, I'm going to do this one in blue over here, n plus 1 plus n plus 2 plus n plus 1 plus n plus 2. So again, we're going to substitute n with the number 2. So we have 2 plus 1 plus 2 plus 2 plus 2 plus 1 plus 2 plus 2. Okay, now I'm not going to do the order of operations on this one just because it's simple addition. So we're just going to go ahead and add these up. Okay, so we have 2 plus 1 gives us 3, plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 10, plus 1 is 10, plus 2 is 12, and plus 2 is 14. So these all add up to be 14. So it looks like Victoria, which we forgot to label, whose work this was, Victoria is looking like she has the correct expression because she had an answer of 14 when we substituted n for 2. So let's go ahead and try Joey's now. Joey has the expression 4n plus 6. Again, we're going to substitute n with the number 2. So we have 4 times 2 plus 6. Okay, we got to solve our multiplication problem first. So 4 times 2 is 8. Then we have to do 8 plus 6, and 8 plus 6 gives us 14. So it looks like both of them actually came up with the correct expression because they both, when we substituted n for 2, came out to have an answer or value of 14. So let's go ahead and answer our problem. So both Victoria and Joey had a correct expression. I know this because when I substituted a value in for a variable, or for the variable, n, all three expressions had the same value. So before we started, I defined the vocabulary term like terms. And like terms meant terms whose variables and their exponents are the same. So if you look at the difference between Joey's expression and Victoria's expression, Victoria's is really spread out. It's really expanded. Let's count how many n's are in Victoria's expression. We have 1, 2, 3, 4 n's. Look at Joey's, 4n. Okay, we added those up together because they're like terms. They're both using the variable n, and they don't, or not both, but they all are using the variable n, and none of them are having an exponent, so we can add those together. We can also add together just the constants, which are just our numbers. So we have plus 1, plus 2, plus 1, plus 2. So 1 plus 2 is 3, plus 1 is 4, plus 2 is 6, and look at that. So it looks like what Joey did is he combined like terms to make his expression more simplified. So that's what we're going to go ahead and be working on today for our lesson. So we have a test the conjecture problem. Let's go ahead and look at our conjecture. It says combining like terms creates equivalent expressions. So we're going to go ahead and test that. Starting with number 1. Number 1 says simplify the expression. Okay, when you see the word simplify, this is just telling you to create an equivalent expression to the original expression, but in a different form. Okay, so we're going to simplify this expression and make it look a little bit different, but they're going to still be equivalent, or at least that's what we're testing. Okay, so what I'm going to do is I'm going to write our expression just a little bit bigger. So we have 3w cubed plus 3n plus 2w plus n plus 4.2. So the first thing I want to do is I want to look and see if I can find any like terms. Remember, like terms have to use the same letter for their variable, and they must have the same exponent if they have one. Okay, so what I'm going to do is I'm going to highlight the like terms in different colors. So I'll do one green. Okay, so we have 3w cubed, and we also have 2w. Now they're using the same variable. They're both using a w. But if you notice on this one, if you notice on this term right here, they're using that exponent of 3. And over here, this w does not have an exponent at all. So those terms are not alike. They're called unlike terms. Okay, we do have 3n and n. Okay, and when I do this, I always want to include the operation symbol that goes with it. So not only am I going to highlight 3n, but I'm going to highlight that plus 3n because that's telling us it's a positive 3n. And then I'm going to highlight the plus n, which is telling us it's a positive n. Okay, unfortunately there's no other like terms that this expression shares, so we're going to go ahead and combine these. So 3n, when I write that out, it's n plus n plus n. And then I need to add another n, a fourth n. So this time now we have 4 n's. So instead of writing this 3n and this n, I'm going to write 4n. Okay, so let's rewrite that expression after we simplified it. So we have 3w cubed plus 4n, so that gets rid of these two for us, plus 2w plus 4.2. All right, so now what we're going to do, actually I already did this for you only because it was a real lengthy problem, but what we're going to do to check our work and make sure that these expressions are equivalent so we can test our conjecture or not is we are going to again substitute a value in for our variable. So we're going to let w equal 3 and n equal 2. So now I'm going to flip to a different page where I've actually worked out these problems for you. Okay, we have test the conjecture number 1. So we've got our simplified version to the left and the blue, and then we have the original expression which was written in the text on the right hand side with the pink. Now I told you it was really lengthy. If I'm following the order of operations and doing things one step at a time so I don't get confused, it ends up being a very lengthy problem. But as you can see at the end here, for my simplified expression, I got an answer of 99.2 when I plugged in w for 3 for w and 2 for n. Okay, on the right hand side, the original expression, again, I substituted w for 3, the other way around, I substituted 3 for w and 2 for n, and I still got an answer of 99.2. So these expressions are equivalent. So as of right now, our conjecture is true, but we need to go ahead and test it a second time just to be sure. So I'm going to hop back to the packet. We are going to say that these were equivalent. We checked them. They are equivalent. And now let's move on to test the conjecture number 2. Simplify the expression. So I'm again going to write it nice and big for us. 12x plus 12 plus 2x minus 3 minus 4x. Okay, so let's take a look at what terms we have that are alike. Okay, so I do see several terms using the variable x. That x on all 3 terms does not have an exponent. So that tells us that these are like terms because they're using the same variable and the exponent or lack of exponent is the same. When we are highlighting or circling or marking up these like terms, it's really important that if it has an operation symbol in front of it, that you keep that operation symbol with it. And I'll start here at the back where we have a minus 4x. Because when we combine like terms, we're going to have to take away 4x. So it's important to keep that operation symbol with it. Okay, we've got the positive 2x. And we have positive 12x. And by default, we know that's positive because there's not a negative sign in front of it. Okay, we also have a second set of like terms. We have these constants. Constants are like terms. They're just numbers and numbers can be added together. But again, we have to make sure we keep our operation symbol with it. Okay, so this is a positive 12 and this is a negative 3. So now to make our lives easier, I'm going to use the commutative property to move these terms around. Remember, the commutative property tells me that I can move the terms as long as, and it doesn't affect the order. So let's move all the green stuff to the left side and all the pink stuff to the right. So we have 12x plus 2x minus 4x. Okay, so those are our three greens. Let me highlight them. Three like terms. Okay, and then we need to add 12. Put this a little bit further out here. Add 12 and then subtract 3. And again, those are our other like terms, and we put them together. Okay, so let's add these terms together. So if I have 12x and I add 2 more x's, that would be 14x's. But then I have to take away 4 x's. So 14x minus 4x is going to leave me with 10x. And it's a positive number, so we're just going to leave it blank, because if you don't see a negative sign, then you obviously assume it's positive. Now let's simplify our red box here. We have positive 12 minus 3, so that's positive 12 and I'm taking away 3. 12 minus 3 is 9, so we're left with plus 9. So now we're trying to determine whether these two are equivalent. Okay, it says combining like terms creates equivalent expressions. So this is where it was not combined yet. I'll just put okay, and here they are combined. Okay, so I did do the work for this one again on the other sheet just to save some time. So we got test the conjecture number 2. All right, so on the left-hand side, the blue expression, we have the simplified version after we added all of our like terms together, 10x plus 9. That gave us a result of 20, oops, I want the highlighter. That gave us a result of 29. Okay, now let's look at the right-hand side, the pink, where we have the original expression, except it's rewritten using the commutative property. We put all those terms together just to make our lives easier. After evaluating that expression using the order of operations, I get an answer of 29. So what does that mean? If the answers are the same, then the expressions are equivalent. So, did we prove our conjecture to be true? We sure did. Okay, because we checked this one by substituting a number in for our variable, and we got equivalent answers because they matched. So our conjecture this time is true. All right, guys, I will see you during your Zoom meeting. I hope you